Yeah, I guess we can start.
Okay, well, welcome everybody, and thank you so much for inviting us, allowing us to come and speak with you today about neuroscience. We're really excited. We are NorthWest Noggin. My name is Bill Greiser, and I teach neuroscience. I teach about the brain in Portland, Oregon. So in North America, near Canada. And it may be snowing today here, actually. So it's the middle of winter. And we love just studying the brain, learning about the brain. We're really interested in like why we perceive things the way we do, why other people often perceive things differently than how we do. You know, what's going on in our brains when we make decisions, when we remember, when we tell a story, when we, figure out, who we are and, what we want to do next and things like that. And we love exploring all this through making things, through, creating artwork, often around, what is actually inside, our heads. Like what is our brain actually made of? This is a 3D printed brain. It's actually based on a real person's brain. But they have their original brain and we got a copy. So it's kind of interesting to look at it and realize that we are also a brain examining a brain. So we brought a whole bunch of folks today. I'm going to have them introduce themselves as well here. So Natalie, do you want to start?
Sure. Hi, guys. My name is Natalie. Um, I was actually one of Bill's students when I went to Portland State University. And now that I've graduated and I am doing research at the University of Washington in Seattle. And so I'm a little bit closer to Canada than they are. And it is also very cold here, gonna get a little bit of snow. But yeah, I'm really fascinated by the brain. Right now, I'm studying how we sleep and how we can sleep better, and how things that may um, change the way that we sleep based on how you structure your day. A lot of people think that to sleep better, you have to do something at night, like turn off the lights and stuff, but you also have to do things during the day to help you sleep better. So if you have any questions about that, I would love to share more.
So Alan, do you want to introduce yourself next?
Sure. Hello, my name is Alan. I'm a current student at Portland State University, and I'm in the neuroscience minor here, which just means that I'm taking a lot of different neuroscience classes along with other classes related to psychology. And my current research is, I'm just starting. My current research is on how stigma and shame impact the development of personality disorders.
Thank you, Alan. Yeah, and Becky, do you want to go next?
Sorry. Hi, I'm Becky. I am also a student at Portland State. This is my last year. I am going to go into school to be a counselor next year. And I'm just here to answer any questions you guys have.
Thank you, Becky. And Angelique, you want to go next?
Yeah, hello. My name is Angelique, and I am a graduate student, so similar to Ablaron. I am doing research on the brain, and I specifically study octopuses, so marine animals, and I study how they think about what they see, and how they're able to kind of create a picture of their world similar to how we do, and kind of asking if they really do it similarly or if they have some different tricks in order to create the picture of their world.
Angelique,
Oh
thank
my God,
you.
Angelique, I just wanna comment actually on Angelique's research. That's so fascinating, working on octopuses. And the students here, you guys met a marine animal in our visits. Could you tell Angelique what kind of marine animal that we went through last time?
Yeah.
Dolphin.
Yo,
We did see dolphins. We did see dolphins.
Nice. That is awesome.
Kareem has his hand up. Do you want
Yeah.
to ask a question, Kareem?
No, how Mr. Abdul Qadir just asked how take the submarine. We've seen octopus, a megalodon, and a whale that floating in air. I don't know why, but anyway.
That's one of our crazy learning classes where we just tour the entire ocean and see these crazy stuff. And I'm just glad that like these animals are being actually doing research on. Actually, I want to ask Angelique a question. Like, why are marine animals specifically important for understanding the brain?
That's a great question.
Yeah, that's a really good question. I think that it's important to kind of study all animals if we want to get an understanding of how brains in general work. And kind of, I'm really curious about this question of, is there kind of one way to make a brain? Like, even though brains from humans and dolphins and octopuses all look really different, is there kind of these things that they all need in order to complete the tasks that they can do? And so I think that studying marine animals specifically in their brains is really important because they clearly live in a completely different environment than us. And it's really valuable to both find similarities that their brain has to ours, and also some differences. Like, there are things that, we can't do. Like, some marine animals can sense magnets in the world, and we can't do that. And understanding kind of how their brains do that might help us
Yeah, it's like
better understand a
superpowers.
lot of things.
I want to make sure
Okay.
that Selma, do you want to introduce yourself as well? Cheers.
Sure. Hi, my name is Selma. I'm guessing you're wondering where I'm from. I'm from Egypt, which is right next to you guys. So my family is from there, but I'm born and raised in Portland, and I'm currently an undergraduate student at Portland State, and it's my last year. And I'm also doing the neuroscience minor, and I'm currently doing some research at the hospital near us on child brain development. So we're looking at children from before they're born. So we actually meet with their mother a few months before they're born, and then we're gonna follow them for 10 years and see how their environment affects their neurodevelopment.
And you'll be able to read about it too, right? On our
Oh yeah.
Salma's writing a post, so it should be publicly available. You'll be able to take a look and learn about the research that's being done pretty soon. So, and Jeff.
all right. So I'm Jeff. I am an artist. But I also teach up at Portland State University. I teach along with Bill. In fact, Bill and I teach art and neuroscience classes. So we talk about the brain and our behavior and how it makes us who we are. But like Bill said, we like to make stuff. So that's what I do. I make stuff, and I want to talk about making brain cells, neurons, out of things you have around you today. So, yeah.
So was it which cup of coffee? Oh, that's great.
Oh, oh yeah.
I think we all have coffee, right? What time is it where you are?
Oh, yeah.
What is it, guys, in Gaza, Egypt? This hour.
It's 6 p.m., 6:15 p.m.
Okay, cool.
Damn.
6:18.
Okay, I think so. Yeah, so we're 8:18 in the morning right now here.
Yeah. We need our coffee.
We need our coffee. So, do you guys have any questions? Any more questions that you'd like to ask? Salma or Angelique or Becky or Alan or Natalie, or any of us too. Before we'd love to introduce an art project and stuff like that, but we're really curious. We understand you've been studying the brain with Abdul Rahman, right? So you've learned about different parts of the brain, right? Are there questions that you guys have? You could totally unmute yourself if you want to, or put something in the chat. Yeah, Jude. And I apologize if I mispronounce your name.
My name is Jude, and what does you got about the brain?
What does you, sorry, what did we, it cut out suddenly.
Interested in the brain.
Oh, what got you interested in the brain, you guys? Yeah. So who wants to go first? Alan, go for it.
I'd be glad to. Yeah. So what got me interested is that growing up, my brain and the brains of my friends are a bit notably different than the average person's. I'm autistic, and a lot of my friends have different neurodevelopmental disabilities like ADHD or autism spectrum disorder, or there's a couple others. And I got really interested in how physically my brain is different than other people's, and how theirs are. And that sort of led me into psychology as well, just trying to wonder and being interested in learning how, if someone has a personality disorder or an anxiety disorder or things like that, how their brain is physically different, and how it changes over time.
Hi.
I like that a lot too. I mean, I really felt the same way to a large extent, because I was always curious, why I saw something in a particular way, or why I felt a certain way. And then I would listen to somebody else and they had a different experience. And I thought that was very interesting. And I actually got very curious. I wanted to know more about what their experience was. And it changed me a little bit when I would listen to other stories, right? And adapt and change my story. And then I want to know what's going on in here. How does that impact me? How does our world impact us, right? And change us physically. So that's really, really cool, Alan. Who else wants to go? Why do you guys, what got you interested in neuroscience? Selma.
I can go next. So growing up, I have a nervous system disorder that when I was really young, probably around your guys' age, I would start to pass out and have what's called a seizure. Do you guys know what a seizure is?
Yeah.
Yeah. So I would experience those, and I knew it was something about my nervous system that wasn't working as it should. And in order to prevent my episodes of passing out and having seizures, I would learn how the nervous system worked so that I could understand what the triggers are for those things. And it was really interesting because you kind of learn about the entire body. The nervous system, it's not just the brain, it's every single organ that you have, all of your muscles, even your eyes, your pupils, how big they are, that's also the nervous system. And there are some parts of it that you control, yourself with your brain, like you think about moving your arm, and then you do that using your nerves. But then there are also other parts that just happen automatically. and that's called the autonomic nervous system. But yeah, and so that was my original interest, and it just kind of went from there. And I think that's a really common experience is you find what you find most interesting about your own experiences and you chase it and you keep learning about it and you go from there.
That's very cool.
So
Who
Trey,
else?
I have a question for Natalie. Can you remind me what's your specialty, sorry.
Yeah. So in my undergraduate years, I studied language and bilingualism. Is anybody here bilingual? Can speak more than one language?
Yes.
Yeah, I can speak.
Awesome. Yeah, so I studied that for a
Yes,
while and yeah, and now I'm studying sleep. And in the future, I hope to study more about the inner structures of the brain and how they connect together.
Actually, can I ask the students to share with Natalie a structure inside the brain that they know, and maybe Natalie can say how this structure is connected to language or sleep or anything that you study. So students, if you remember in our classes, like we talked about a very specific a part of your brain that's inside it, you know? So could anyone tell us what is it? And for Natalie to tell you more about it and how it connects with her work.
hippocampus and amygdala.
Oh,
Bravo.
Yeah,
All right.
yeah. So
So
amygdala.
Natalie, can you tell us how what Muhammad perfectly said about the hippocampus and the amygdala and how they connect to what you study?
Yeah. So I feel like those really connect to sleep a lot. So the hippocampus, we know that's the memory center. And you know, the day before a big test and all of your teachers and your parents tell you, get a lot of sleep. Don't stay up studying. Not that you shouldn't study, but that you should make sure you get really good sleep. And that's really important because the way that we form memories happens during sleep. There's different kinds of memory. There's short-term memory, and then there's long-term memory. Maybe you remember what you ate for breakfast this morning, right? But what about December 1st? What did you eat for breakfast on December 1st? Probably don't remember that. So some memories are not as important and you're going to throw those away. And others, like what you learn in school, are really important. And so you want to keep those. So during sleep, the hippocampus is involved in sorting out what memories do you want to take with you into the next day and into the future. And then the amygdala, that is also pretty related to memory in terms of kind of assigning like a lot of fear or emotion values to specific memories. And those make it more, they grab more attention in your memory.
I guess Badr has a question.
So
Yes,
I know, like,
Okay, let's hear from Badr and then we can hear from Karim.
Why you all specifically choose the nervous system or brain to study about?
that is a great question. And I know that Alan, right, and Natalie started to answer that, but maybe Salma, do you want to explain where you got the interest or?
Sure. So back when I was, I think I was 7, there was a science museum near where I lived that had an exhibit where we could, about brains, and I got to hold like an actual brain, like it was someone that had passed away and donated their brain to science. So I was really interested. It was super cool. And then fast forward to when I started college, I was really interested in psychology. So that's actually what I'm studying. So from there, I was like, I wanted to understand like the vessel in which we do all the thinking, everything that psychology entails happens in the mind. So I thought it would be good to understand how that works. So that's how I got into neuroscience.
That's awesome. And actually what we do with NorthWest Noggin, what we like to do is actually go to classrooms, right? And we go to all sorts of places, to places where there are young people who don't have homes. We go to what they call houseless youth kind of nonprofits, and also to correctional facilities where people have, been incarcerated, been put into a kind of a jail, actually, to talk about the brain. But we bring, like Selma knows, right? We actually bring actual brain specimens so other people can kind of hold them and examine them. And also, I think, get inspired to learn about like what makes us who we are, right? And how the brain is involved in all of that. So, Angelique, how did you get involved?
Karim also had a question.
Oh,
Yeah,
sorry, go for it.
Kareem.
So I know a little bit about this, how the sleep happen in the brain, and I remember like it's structure connected to something. I remember it's like the hypothalamus or something like that. And there's a lot of steps that how we get sleep, like the REM and the non-REM sleep, that all of I know of the sleep in the brain, how sleep.
Excellent. A really amazing thing that we've learned pretty recently is that the non-REM sleep, like the REM, that's REM, that stands for rapid eye movement, because your eyes are moving back and forth. If you see somebody who's, in that kind of sleep, you could see their eyes going back and forth. And if you wake them up, they usually report that they're in the middle of some kind of a dream. But the non-REM sleep is very deep sleep. And we've learned that in the brain, the brain needs blood, right? It needs the oxygen that you breathe. It needs the sugar that you eat. It needs all the stuff to keep it going. And there are all these little blood vessels. They're called capillaries that run all the way around the brain, all the way through the entire brain. And around those capillaries are these really cool cells that are called astrocytes. And they wrap, some of their membrane around the capillaries. So when you go into a very deep sleep, that like amazingly, restorative sleep, that non-REM sleep, you see the astrocytes pull back just a little bit from the capillaries, and all the fluid around your brain and spinal cord courses through your brain and cleans it out. It cleans out lots of, stuff that is built up during the day and things like that. And that's a really important thing, because you don't want all that stuff kind of building up. So if you get really good sleep, you always feel like, I've cleaned out my brain. That's actually what you have done. And if you don't get good sleep, you're like, I feel like I've got all this stuff in my brain. And that's what's happened.
Me.
Yeah, Bader, I think you've got a question. Yes.
I think I know about something about the brain. It's like a sickness of all people. When you imagine something and you see it before you sleep, it's called daydreaming.
Yeah. Daydreaming is, daydreaming is really important, actually, because it allows you to kind of reflect on things, or to maybe imagine things that might be, to remember things and tie them to potential, decisions or plans that you might have. So it's good to daydream. Daydreaming can be good. If you stress about something, if you can't stop thinking about something, then it can be a little bit more complicated, right? Because it can make it hard to go to sleep, right? So
yeah, and I think I also want to highlight.
It's hard to see.
And then it's hard to sleep. Exactly. If you can't turn that off, that's very difficult to sleep. And you need that sleep. That sleep will, as Natalie said, help you let go of some things that are not helpful to keep holding on to. But we understand that, like, all of us have had those experiences, where your mind is racing, right? You just can't turn it off. there's actually parts of the brain, deep in the brain, that are very much involved in this. So below the outer part of the brain, this is called the bark or the cortex of the brain. Below it, there's neurons, there's brain cells that we'll talk about next, that connect with each other in these networks. And they're called the basal ganglia. And the basal ganglia are really important for when you start moving, stop moving, and then how fast you move, right? But they're also, it turns out, really important for when you start thinking, when you stop thinking, and how fast your thoughts are racing, right? So if that's happening to you before bed, you can say, okay, basal ganglia, quiet down. Because, we learn over time, to try to use the cortex, the top of the brain here, to try to control, to sort of slow down the basal or quiet the basal ganglia or channel the basal ganglia. Like sometimes if your thoughts are racing, there's like a lot of energy involved, and you can maybe utilize that, right, to do something, and you can think of something good to do. So yeah, I had lots of hands up. This is great. Farah, do you have a question?
Yeah, I heard that if you don't like sleep a good amount, that your brain can like eat itself.
So Natalie, you're the sleep person here, right?
Yeah. So in terms of eating itself, I don't know how exactly that would work, but I know in terms of energy, the brain needs a lot of energy throughout the day. And if you don't sleep, you can't recharge your batteries. And so I think in terms of that, when your brain doesn't have that energy, then it makes it really, really hard to function the way that you usually would. And the term for that, the longer you've been awake, the more tired you're going to feel. The term for that is homeostatic pressure. But in terms of it eating itself, I'm not too familiar with that. Maybe Bill, you could chime in on that aspect.
So the problem is, remember, if you don't get that really deep sleep, right, where you get the fluid coming through and cleaning stuff out, well, that stuff, that collects. And a lot of it is from all the energy that you're expending actually during the day. There's a lot of activity in the brain that goes on, and there are kind of waste products that that have to be removed from the brain, right? And so if you don't clear it out, then it starts to collect a little bit. And then it can, make it harder for the neurons, for the brain cells to talk to each other and to function properly. So all of us know that feeling, right? If you didn't sleep very well the night before, you don't function as well, during the day. You're tired, you're fatigued, and part of the thing, the concern is like, if that happens in the short term, all of us deal with that, and then you get some good sleep, etc. But if it persists, right? If it persists over a long time, then you can really collect a lot of this stuff that shouldn't be there. And it can, cause some more long-term problems. Like there's,
And also,
yeah, sorry, go ahead.
and also we talked about the hippocampus and the amygdala. So they actually found that your hippocampus and your amygdala are highly active in sleep. And what that means is that if you are studying for an exam, your brain is literally trying to store what you studied in your hippocampus. So sleep, this is also, as Bill was saying, how your brain cells, they were making all these connections and networks that are your information, and the things that you studied or the things that you learned and the emotions that you felt. While sleeping, the brain kind of saves them and goes into a process to just all this information, just observe them.
Another really good piece of information just to have about the hippocampus and about the amygdala and about sleep is that we found that like when people don't get a good night's sleep, when they see something happening the next day, when they have, they talk to their friends or something happens, etc., they will have a much more negative like interpretation of what's happening. They won't be like kind of like, oh, that's funny or something like that. It'll be more like, no, I don't like that. They'll have a less positive like impression of what is happening. So if you haven't gotten a lot of good sleep, then it's sometimes good to stop for a second and say like, okay, I don't like what's happening, but maybe I don't understand completely. Maybe I'm taking a slightly too like it's too negative, and ask somebody like, so what do you see that's going on right now? Just to step back and slow a little. Yeah, so many questions. Okay. Zhao Mi, I don't know if I'm pronouncing that correctly, but I have XIAOMI and then M2101K7AI.
Tell me.
Okay, good, cool. Cheers.
And also, if we didn't get a lot of sleep for kids, there will happen something for them. They will be sick and go to the hospital because they didn't get a sleep or enough sleep. That's why, because the sleep is an important thing in your life.
Absolutely, Mimi. Actually, it's amazing. Like, there's a part of your body, it's called the immune system, right? It fights off infection, it fights off viruses and things like that. Well, it turns out that sleep really strengthens your immune system, and lack of sleep can harm your immune system. So, yeah, so it's really important to, get that sleep. So, actually, I think the most important thing we're learning here, right, is that everybody should try to get good sleep. Like if you need sleep, they should say, okay, like that's a priority. Let them go to sleep, right? That sounds good. So we have more questions here. How about we take a few more, and then Jeff, do you want to introduce the art project?
Yeah, absolutely.
So let's do a few more. So let's see. I see Gadir, you've got your hand up.
How do we get more sleep hours? More deep hours?
How do you
Deep
get more
sleep hours?
Oh, there's a lot of good advice I'm sure people can offer here. For how do you get better sleep? Although none of us get really great sleep, right?
So one thing we can do is at night, be sure to reduce the amount of light that you get. It's really tempting to stay on your phone or keep the lights on to work on homework and stuff, but really the most important thing is to reduce that amount of light that you're getting. If you want to read, try to read from a book rather than your phone, just with really dim lights, and especially blue light you want to avoid during the evening time. Sometimes your phone can have a setting where at night it'll make the screen red so that if you do have to use it, it can at least be the best kind of light to get pretty late. And then the other important thing is in the morning time, you want to get that bright light exposure that really helps your brain and your bodies. It's called your circadian rhythm. The daytime part of it is just as important as the nighttime part of it. So controlling the light, bright light in the daytime, especially right when you wake up, is just as important as having really dim and more red light towards the evening.
That's excellent. Yeah. And it helps to try. Can often be very difficult because not everybody can manage this, right? But if you have an opportunity to try to go to sleep at the same time, right, in the same place, and that is, not always easy, obviously, in many circumstances. When we work with a lot of youth who don't have places to sleep, they are houseless, they don't have a home. They talked about how difficult it was because they were spending a night in a different place each time. And when our brains, when we go to a new location, we're on a higher state of alert because we don't really know, what the circumstances are in this new location. So it can be a little harder to get to sleep like the first night or two. But if you're in the same place for a bit, if you can make a routine, like you go to sleep at the same time, in the same sort of place, that can be helpful too. Because all the the stuff around you will kind of lead you back to that sleep. So these are great questions. So Abdulrahman, do we want to talk about the art project a little bit, and then we can take some more questions after that and stuff? Is that good? Or
Yes, let's talk about the project.
Yeah.
Okay, cool. You want to make art?
Yeah,
Right.
I guess the students want
Yeah.
that more. So let's do that, and then maybe we
And
can.
then we'll do more questions because I see there are more. So
Yeah.
Jeff, you want to go for it? Mhm.
All right. So I'm going to go ahead and, if it's all right, share my screen
Yep.
for a minute here, just because I want to show you some examples and things that we've done before. So
You're a co-host now.
all right. Great. All right. And also, I don't know if how much you have all looked at neurons before.
No.
Okay. Well, that's all right.
Here, I'm gonna go ahead.
Yeah, and Bill can show you. He's got lots of neurons also. So the neuron is a brain cell. And there are other types of brain cells, but most of the time when we talk about brain cells, we're talking about neurons.
Yeah. And also, some of the Egypt's people sleep like at 1 o'clock, at 5 o'clock, at 6 o'clock. They are very late when they are asleep.
But then they take a nap in the afternoon, right? Yes, exactly.
I'm surrounded by like 50 Egyptian people right now. I just hope they don't hear you, Mariam, and just come and take the phone from me.
That's funny.
All right. So neurons. I saw actually there was a question in the emails that we were looking at that people were asking about how many brain cells we had. It's interesting. So these brain cells, these neurons, you're born with maybe 200 billion of these in your brain. So that's a lot. But when you get to my age, maybe and I'm being generous here, I probably have around 86 billion or so of these. So you get less and less and less. But the neurons themselves, they form big networks and they talk to each other in your brain. And over time, you lose some that you're not using, but the ones that you use, the connections get better for the things that you do. So it's important to practice things that are that you want to do and that are helpful to you. And the more you practice those things, the more you do them, the better you get at them, because these neurons get better and better connected. So these neurons, though, even though there are lots of different shapes and forms of them, they all have basically the same parts and they work in kind of the same way. So that's mostly what I wanted to show you, kind of what they look like and some of the basic parts. And then we can talk about how you want to make your own neuron. So these neurons have, they look like weird sort of trees, maybe like little plants or something. They have all of these branches on them, and you can see it has kind of these branches that come off of the top here. These are called dendrites, which is a Greek word. It means branches. And that is the part of the cell that takes in a signal. So it comes in through the dendrites. And then it has this big round part, which is a cell body. The cell body is It does a lot of things, but one of the things it does is it kind of is the part of the cell that decides whether it's going to send a signal or not. So, or whether it's going to continue sending a signal or not. And then also the cell has like this weird long part, this kind of wire, which is kind of the really interesting thing about these cells is that they send a signal down this wire to all over the brain to talk to each other, and really all over the body actually too. And they can be really long, even though they're very small still. Yeah, learning more and more. Yeah, it absolutely can. Yeah. The more you do, the more brain cells will kind of stick around. And you know, we used to think for a while that you didn't grow more brain cells, but to a limited extent, at least, you can actually, by doing new things, by kind of going new places, that sort of thing will actually help you grow new brain cells. So, yeah, so this wire part, this is the axon of my neuron, and it carries an electric signal from one end of the neuron to the other. And that's the interesting thing about your body, your brain uses a lot of electricity. And then it has these, all these branches that kind of come off the end. They kind of look like roots of a plant or something. Those are the axon terminals. And that's the part of the cell that then sends a signal on to the next cell. And they're kind of interesting because it's an electric signal in the brain cell, in the neuron itself. But when it reaches that electric signal reaches those axon terminals, it sends chemicals out onto the next neuron. So they talk through electricity, but then through chemicals to each other, or these cells do. So, and those chemicals we call them neurotransmitters, and there's lots of different kinds. Some of the ones people have heard of more are things like dopamine or serotonin, but there's lots of them. And in fact, many of the sort of medicines we take or drugs we take are operate just like these neurotransmitters, things like coffee does. So yes. All right, so those are the basic features, and I just wanted to show you that because to get you thinking about when you look around yourself, like what do you see that might look like some of these things. So I have a few images. Sometimes we just walk around and we see things that look like brain cells, even like cracks in the sidewalk or plants or trees, or there are lots of things that you think that looks like a neuron to me. But one of the things we really like to do is like to have people just make neurons, these brain cells, out of things they have around them, but also things that are interest them. Like we had one friend who was going through medical school, so he's going to be a doctor, and so he made his neuron out of things from his first aid kit here. And I think he has his little part of his stethoscope here too. So lots of things that sort of interested him, but they also, he was thinking about how the neuron was shaped and kind of what it did, but he told us a little bit about what he did too himself. So let's see. I have lots of examples. Oh, the other thing I did want to tell you, I just, neurons come in lots of different shapes and sizes, and they have different configurations, but all of these types of neurons have the same parts. They have dendrites, they have a cell body, they have an axon, and they have axon terminals. So but they can come in lots of different shapes and sizes. So, all right, some neurons that we make, and what we thought is that you would, if you go when we're done with this, think about your brain cell and kind of what you might want to make it out of that sort of tells us something about the shape of the neuron, kind of what the different parts do, but also maybe something about what you like. This is one I made out of, I like to paint. So I have brushes and palette knives and a palette here. And so I made my neuron out of painting things. I think this one Bill made, actually. He made a neuron out of stuff in his he found in his junk drawer. So, and there are lots of different parts that I didn't go over, but if you look, I mean, they have all kinds of parts like, you know, insulation around them, myelin, or the, you know, Bill even has neurotransmitters in his with little screws here. So, all right, let's see. Oh, here's one of our students made with noodles. One with celery. Like this Coke can neuron with paper clip neurotransmitters. I like this one too. It has you think, what is that, Bill? Kale and broccoli? And
broccoli. It's
yeah,
very much like from Portland, Oregon.
I like the coffee neurotransmitters on this though. Office supplies.
That's pretty cool.
I like the matcha neuron. We had a student who was really into matcha. So
that's beautiful.
Yeah, you can see the brush for it, the cup, and the neurotransmitter matcha also. So
that's excellent.
Yeah.
Oh, I love that one.
And this is these are parts of a game, like a board game. So we had a student who is really into board games. And a student who is really into music. So these are audio cables and connectors and a record cell body. And I think those were all my examples, but I just wanted to show you some things. So when you when we're done with this, just take a look around you, but also think about the things you like. Think about the things that are kind of maybe important to you, that you can tell us something about yourself with. And also maybe think about even what these different parts of the neuron do, like that axon carries a signal. So do you have things that carry a signal, or do you have things that might take in information that could be a dendrite? Or do you have things that you know, send a signal on, that could be an axon terminal, you know, so those sorts of things. But the thing I really like about these cells is that you know, they're sort of like, to me, kind of a self-portrait. So this is your self-portrait as a neuron. All right. I'll go ahead and stop this and let us continue. So if you have questions though, or I love hearing people's ideas too. everybody's so creative with these that it's a lot of fun for me to see what people make and what people come up with.
Gadir, are you making a neuron right now? That's super cool.
It's Muhammad, yes.
That is beautiful. Oh,
Okay.
you guys, those are awesome. They're already being crafted as we speak, right? See, one of the cool things about having so many neurons, right, when you're younger, is that they can wire up in so many different ways, right? You have such potential. They can become all different types of pathways. You could learn all different skills, right? That's one of the coolest things about, being a younger person, I think, is, there's unlimited possibility. That's really cool. Are there more questions? I see Salma, did you have your hand up?
I have a question.
Yeah, please, sure.
Can you hear me?
Yes, we can.
Okay. Why and how do some people think faster than others?
That's such a good question. Who wants to take that question on? It's a complicated question, because, for example, people can react faster to certain things, and respond quicker in certain situations, maybe because they've had experience in those situations before, right? So it's sort of second nature to them. Other people, I think it's interesting. There's those structures we talked about deep in the brain called the basal ganglia, right? Which are involved in when you start, thinking, when you stop thinking, and how quickly you think, right? So, people have had oftentimes good sleep or something like that, right? And these systems are really going and they're maybe speeding up and stuff like that. Maybe they can deploy them really quickly or a little more quickly in certain situations. But that's in some cases that's not the most important thing. Like especially if people respond like super fast to something and reflexively to something, maybe a little bit more slow thinking, like consideration, right, is important or could be useful in those circumstances. I don't know if anybody wants to chime in or.
Well, the one thing I'll say that like I was saying, before, those neurons that you're, using for, developing the things that you do, you all know that, when you practice something, you get better at it. You can it's easier over time. Well, part of that is that the connections between those neurons, they get better, they get stronger, and they're kind of able to operate a little better. So that's one reason why you might be able to not necessarily think faster, but think faster for the things that you have practiced, the things that you have kind of become used to doing. So.
Does let's see, Kareem, do you have a question?
What are the main parts in the brain?
Who can tell us the main parts of the brain? Maybe, how about Angelique, you can compare it then to the main parts in the octopus brain.
Yeah, there, I guess, are a couple different sections of the human brain, and octopuses have some of the same sections. So we have, I guess, like Bill was saying, kind of the outside of the brain, or the bark of the brain is called the cortex. And within that, we have lots of different sections that help us make decisions. Like in the front is the prefrontal cortex. And then in the back, we have the visual cortex. And in the octopus brain, in a lot of invertebrate brains or animals that don't have a spine, like insects and octopuses, they don't have a cortex, so they don't have this big kind of area with all the grooves on top. But they do still have areas that help them make decisions or help them see things and make pictures. And they're called a little different, but they still kind of have the same structure that allows for memories and decision making.
You know, at OHSU, which is a local research institution in Portland, Oregon, they do a lot of research on songbirds and how they learn songs and learn language, really. And while they don't have the same type of cortex that we do, you know, where our language networks are located, they have the same circuitry. You know, it's basically the same pattern of interconnections across structures in their brain. So it's kind of interesting. Like, yeah, like the same with the octopi, right? There are some similar sort of structural organization. There's a sort of certain kinds of functions, but maybe in slightly different places, right? Things like that. Yeah. Kadir, I see your hand up, and you have a beautiful neuron.
Building.
That is incredible. You got all the parts. That is very, very cool. Yes, I'm gonna clap too. Oh, sorry, Mohammed. It's Mohammed, right? Not Gadir. My apologies. Mohammed, that's a beautiful neuron.
But is my mom name.
Yes, I got it exactly. It shows up on the screen, but I know it's your neuron and not hers, right? Selma, do you still have your hand up for another question, or?
Yeah. I
Please,
actually have
Nora, yeah,
another
yeah.
question.
Of course, yeah.
Why do migraines hurt so much if the brain doesn't have any pain receptors?
That is such a good question. Does anybody want to take that on about migraines? So, you know, even though the brain doesn't have any pain receptors, like the receptors that actually respond, that lead to a sensation of pain, actually are responding to injury, like to injury to the head or injury to the hand, like injury to cells.
I want to ask a question.
Oh yeah. Oh, and I will do you 1 second. I'll just answer just about migraines first, and then we'll totally take your question next. You're next. So the issue is, while the brain doesn't have the receptors, it receives information from those receptors, and in the brain is where you feel the pain. So when that gets mapped in your brain, people experience that often as pain. So there's a certain kind of migraine headache that involves like one side of the face really intensely, and so all of the receptors, the neurons that are carrying information about injury from the face on either side, they work their way back into the brain, right into the brain stem and up to the brain to map. And they have all their cell bodies, like that Jeff was talking about, all those soma, those cell bodies, located in these big clumps, and they're actually right above your, in the back of your mouth, the roof of your mouth at the back. They're called ganglion or ganglia. There's one on the right and one on the left, right? And they're carrying information about injury and other things like touch and everything else from the face, heat, cold, etc. And there's a lot of blood vessels right there that go right past it. And in migraine headaches, sometimes there's a change in how the blood is flowing. Like the blood vessel can get big. They say dilate, it gets larger, and it can put pressure on those cells. And when that happens, people have often like a lot of pain. Like the neurons start signaling inappropriately. It's not accurate in terms of what your face really is feeling. But in the brain, then it gets mapped as if you're in, you know, significant pain. I don't know. Do you guys ever have ice cream? Have you eaten ice cream or something really cold? And if you put it in your back of your mouth and it feels like like that pain, that also causes the blood vessels back there to like get really small, and then they get really big. And when they get really big, they put pressure on the same spot. And people have this, we call it an ice cream headache, and it's like but luckily you take the ice cream away or you take the cold thing away and you feel better pretty quickly.
Yeah, it's called a brain freeze, right?
Brain freeze. Exactly. Yeah, brain freeze. Absolutely. Yes. That's exactly right. Yeah, so it has a lot to do with the flow of blood. Actually, migraine headaches, like some people with migraine headaches also have these interesting kind of, they're called auras. They have like before the migraine really hits, they maybe see something strange. So they'll see, like very commonly, people will see like these like jagged, like it's like a jagged lines forming kind of a semicircle that's shimmering, and then it kind of moves across your field of view. And that's because the blood flow changes that are, not accurate. They're pulling blood away from the brain tissue so it can't properly function. It's in the visual cortex, like at the back of the brain. And so it disrupts how you see. Other people have these auras where it's happening in a part of the brain. This is called the parietal lobe. So Angelique told us this was the frontal lobe, right? This is the back. This is where actually all your visual information, your eyeballs are here, but the visual information goes right back here first. But then it gets shared up into the parietal lobe. And this area also gets information about what you're touching and like where you're located in space. Like if you close your eyes and you can touch your nose, right? How do you know that? Well, you're mapping the body in the parietal lobe. So if you have a migraine sort of disruption in the parietal lobe, people get these odd syndromes. They feel like they're getting very small and everything else is getting very big, or they feel like they're getting very large and everything else is getting very small. They're weird disruptions of like how you perceive your own body in relationship to other people and other objects and stuff in your environment. So it's pretty remarkable, actually, how the brain is really important, right, for all of these types of experiences. Who was going to ask the question next? You please go ahead and ask, right?
Me.
Yes, you.
Have you ever think to visit Gaza?
Oh, we would love to visit Gaza. Actually, if as you know, right, our government is horrific at the moment, and I mean, it's very hard to get any. I mean, it's not even an opportunity, for us at all. So I mean, but I love that we have at least this opportunity to talk with people, right, and to hear from you, and to see some of the extraordinary art, that you are already creating there, right, Mohammed, right? So, and Mimi, I saw yours too. But yes, at some stage we would love to visit if there's some opportunity, right? I don't know if anybody else wants to add anything or.
We have some hands raised. I just rejoined. I don't know if these questions were already answered, but we have the two Karims and Salma and Badr.
Yes, please go ahead.
Okay. Okay, I'm gonna go the way they are ordered on the Zoom. So let's start with. Oh, Badr. Badr, you don't have the question?
Yes,
Or was
yes.
it's
Sometimes when I put my right hand on something, my brain told me that I should put the left hand on the same timing and on the table. I repeat words to say it perfectly.
Yeah, that's a complicated. There's a lot of complicated like sensory input. You got to be able to know where your body is located, right? You got to if you're looking at something to touch with both hands at the same time, you have to be able to see and combine that information, right? And you got to move. You got to actually send the output. Basically, you've got long wires that come from your spinal cord, come from your brainstem to move your face, right? To move your body. We are pretty remarkable in terms of what we're able to do. One of the things we've been learning a lot in our classes in Portland is how, in some ways, we get rather limited information, right, about the world around us. And the brain is always trying to create like a model, come up with a story that explains, what we're perceiving, what we're detecting, and how our actions have consequences, basically on the world around us. And that's amazing. That's why we love this because you know, these models that we come up with, right? These stories that we tell ourselves are a product of our experiences. So it's really powerful to meet other people who have different experiences and have come up with, you know, different insights and have unique and valuable stories to kind of share with us all. So yeah, we're very excited to have your questions here and to be here actually and be joining you today.
Amazing. Thank you, Badr, for your question.
Yeah.
Let's Karim Shat.
Oh yeah, I have one question. Like, if there is something pushing on the brain, like a cancer or a brain tumor, would it affect on the emotion or on the memory?
So go you guys. Somebody, what do you guys answer? You could totally answer that question. What do you think, Natalie or Angelique?
Yeah, I can take this one. Yeah, it definitely would give you different effects based on where the brain tumor is. And actually, that can give us hints to find it based on what symptoms or the effects that you're having are. If your symptoms are more about your body and like how your movements are, that might be more in the parietal area because that's the part of the brain that controls both the input. Yes, thank you, Bill. That is the part of the brain that controls the input and the output of moving and feeling your body. But if you are seeing different things and or if your sight is just going away, that might be more towards the back of the brain because that's where the visual processing happens. Or if your emotions are acting a lot differently, if you're really quick to lose your temper or something like that, that would be more towards the front of your brain, the frontal lobe, because that is where a lot of your emotions are processed and your ability to regulate yourself.
Great explanation, actually. And I think the students here know how we can see where the tumor is, like what machine we use. So anyone wants to jump in and let us know the name of the machine that we use in hospitals to see? What?
MRI.
Exactly. It's an MRI machine, but add an F to it because it's the same concept, but an fMRI actually. I think one of the volunteers can talk about the difference between what is just MRI and what is fMRI.
Angelique, you want to do that? Or Selma, are you using that for some of the research that you are engaged in at OHSU?
Oh, we are, but I'm not really involved in the MRI process.
Okay.
Yeah, I can talk about it a little bit. So there are, I guess there's the MRI and the fMRI. And an MRI is something that you might get if you like injured your knee or your shoulder and you need to see kind of a structural difference, or there's a like just kind of looking at the overall part of the body and seeing kind of what it looks like, not necessarily how it functions or what's happening inside of it, but you're just looking at kind of one moment to see the structure. But an fMRI, the F actually does stand for functional. And so that means that you can see kind of the blood flow and the movement and things that are actually happening at different time points. And so that allows us to see things like what brain areas are activated when we feel sad or happy or think of a stranger versus a friend.
Yeah, that's very that's a great explanation, especially just going back to that tumor, brain tumor, because you can actually see it, like the brain that the brain areas that you know are supposed to be working in people that are healthy, But we also see like if one area is not working in something that is working in a healthy person, then we know that oh, there's an issue here, and that's how I believe many of the students here are interested in the medical field. So that's how doctors can learn, like oh, this person has in that area, as Natalie was saying. So I also think we have question from we did have from Kareem because they were unordered. That Kareem Khalaf, I believe. Was your question answered, Kareem? Oh, he might have been disconnected. All right, so we'll go to Selma's question.
Is it my turn?
Yes. Oh, absolutely.
Oh, how does music impact brain activity and mood?
That's awesome. So the brain, parts of the brain, across the brain, there are long connections with all these, neuron wires, and these areas need to kind of coordinate their activity, right? They send in electrical impulses back and forth across the brain so you can pay attention, right? So you can remember, so you can reflect on things, so you can see. And so there's a rhythm kind of built into the brain. And in those deeper structures too, like the basal ganglia we talked about, that initiation of movement, that stopping of movement, the timing of movement, that's rhythmic. So we are in some ways really music. So the external rhythms that we hear, the music that we hear is very moving to us. It actually can help to coordinate the activity of networks in our brain. Also, music is, very culturally significant. It's, something that we grow up with, right? When you're undergoing lots of development as an adolescent, that music you listen to, in childhood, right now, actually, and as you get into become a teenager, that's going to be music that's going to stick with you for a very long time. And in fact, it's a very powerful, it moves us emotionally, right? Because it actually impacts some of these deep structures in the brain that let us, kind of feel and engage and kind of respond to things that are meaningful to us. So music is extremely important. Yeah, Natalie, please. What do you added some more? Hmm?
Yeah, I was just saying that music is how we tell stories, and stories have important lessons, and that goes for all art, but especially with um, early human history, before we could make guitars and everything. We just had our voices and a campfire, and so there's something really, really special about that, just wired into our brains about being able to pass down these kinds of stories through generations and learn from those who came before us.
And as the students here, Palestinians, and as a Palestinian myself, music has been a very important part of our culture. And it's been like the same music have been, and if any student wants to jump in and talk about this, about their favorite music in the Palestinian culture, but the same music has been traveling through the generations, like for thousands of years, and it's been a symbol for us to be connected to our cultures, to be connected to each other through weddings, through even through difficult times. We find like going back to our cultural music gives us some sort of hope and some sort of inspiration to keep moving forward. And if any student wants to add their favorite Palestinian song or anything that they would add about Palestinian music, please feel free. Okay, I do see some hands. Better, do you want to add to that, or do you have a different point?
Yes. How do blind people? I wonder how if blind people um see the visual pictures in their dreams.
That's so cool. That's a great question. So it's interesting. People can be blind from birth, right? They can maybe have no visual experience. Maybe they don't have the proper or the same receptors, like the same neurons that can respond to light, in their eyes or something like that. And if they have blindness from birth, they tend to report different kinds of imagery. They tend to report more kind of spatial imagery. They do have a very strong sense of space, but it could be partly built up from sound. Actually, a lot of people who are blind from birth, they want to make noise. There's noise. They click, they do all these kinds of noises because they can hear the feedback from the objects, like the echoing off of objects around them. And they can construct a map spatially of where their body is in relationship to other objects and events, and can actually be quite effective at this. But if you, for example, go blind, right? For example, if something happens and you lose your sight, well, early in your life, you had the experience with your eyes to develop the brain, the parts of the brain that let you perceive visually, what's around you. You can see. So in those cases, even if they lose their sight, sometimes they have actually very vivid visual experiences. They can have very vivid visual dreams. And sometimes even when they're awake, they can sort of see things, that aren't actually there. This is actually we learned about this in our classes. As people get older, they sometimes lose the receptors in their eye. It's called macular degeneration. They start to lose that. And as a consequence, many of them report actually having very vivid visual experiences because the information that's coming in isn't as accurate anymore. So they misdirect it, and they start to see all sorts of things, and they start to hallucinate all sorts of things around them. So yeah, so it's a great question. It's really interesting.
We have a hand, Selma. She wants to.
Yeah, please. Go ahead. Yeah.
Yeah, can I ask?
Yes. Oh, absolutely. Yeah, please.
How does aging affect brain function?
Ooh.
I could talk a little bit about this. So, I will talk a little bit about early aging, aging from when you're quite young to around when you're around 25, and then maybe someone else can talk about aging past that. But when you're first born, you have a lot of brain cells. We've already covered this a little bit, billions of brain cells. And what's going on is your brain had undergone what's called neurogenesis, where as many connections were made as quickly as possible. Not all these connections make sense, but a lot of them were made, and there was the emphasis put on quantity, on the amount. And as you grow up, from about when you're a baby to around when you're 25, your brain is doing something called neural pruning, where it's deciding which connections are important and which ones aren't actually helpful. And so as you grow up, especially in the frontal lobes, the frontal cortex, your brain is slowly honing down and slowly getting smaller as the important connections are emphasized and are left, and the ones that don't really make sense, that aren't really necessary, are trimmed away.
Thank you for asking for answering my question.
Thank you for asking.
Selma in Portland, do you have more of that? Because I know you were studying infant development, right?
Yeah, currently our infants are pretty young, but I have through classes read a little bit about the effect of aging and but more specifically with certain conditions like Alzheimer's and dementia, and I've seen that in friends, family members. So sometimes when people age, they develop conditions that cause neurodegeneration, and they lose function, but that's not always the case. And I think there's a lot of research in Portland on developing medicine to prevent that or to slow down that process.
And That's very important. I just want to highlight something Alan said, which is about the neural pruning or the synaptic pruning, and circle it back to autism, which is a topic many of the students here are interested in. Kareem, who's with us, mentioned it in our previous class. It's very interesting how this specific process is different between the brain development of someone with autism and someone who is more into the neurotypical sides. And it's very interesting how the absence or the delay or issues in the process of synaptic pruning kind of doesn't remove all the connections. I like to see it like leaves on a tree. It doesn't remove all the trees that should, all the leaves that should have been removed, eventually leading to neurodivergence like autism. So it's different how just and this happens at the age 2, like when you are just 2 years old. So it's really interesting how um, brain development is very sensitive, and there are so many important processes. Sorry for jumping in.
Oh no, that's really
Absolutely. Yeah, it's really interesting and very relevant, I think, to autism spectrum disorder. I can speak from my own experience and say that, and I mentioned this a little bit in the chat as well, that the way sensory information is processed is in part due to that lack of neural pruning. Like the way that I, as an autistic person, experience texture is, while there are the same general structures and general ways that happens, I'm much more sensitive, and there's some connections in my brain that aren't particularly useful. Like I can't wear certain textures because my brain translates it to painful, where for normal people, not normal, sorry, for neurotypical people and non-autistic people, it might feel soft.
Yeah, even sounds like I was watching a TV show and they were presenting a person with autism, and they showed a scene where someone, like on the cashier, she was chewing a gum. So that voice of chewing a gum, where maybe someone on the neurotypical side, it's like they don't even think about it. But for someone who has these connections in their brain and they're very sensitive to sounds and textures, they hear it and they're annoyed by it. That's why you see many kids, especially with autism, when they're stressed, they kind of just shut their ears off. It's because they're so stimulated. There are so many connections in their brain that's just so much. And I think this way, understanding this point allows us to, in a classroom or on the street, if we saw someone who's doing that, we kind of know that it's just too loud for them because their brain is built differently, and that's okay.
And some people cope with that excess of sensory information by, like, a lot of my friends wear headphones.
Yes.
It helps a lot. It's an accessibility thing. Some people will flap their hands or fidget, and this is a way of sort of getting rid of that stress and that pent up energy from experiencing so much sensory information. And so there's also other uses, but that's why some people like shake like that, and some people wear headphones.
Yeah, and movement is a great way to remove stress or anxiety, because even like I think most people experience this where you're just sitting and maybe you're a bit stressed, so you kind of start shaking your leg. It's basically your body's process of like, I just want to move so I can remove or engage another part of my brain to work. So it's kind of interesting how the brain is like working with 100 million things at the same second. We have a question from Selma.
Yeah, how does the brain distinguish between reality and imagination?
That is such a great question. I think we should throw that to Jeff. You're the artist.
The sort of interesting thing about that is that the brain doesn't always distinguish between reality and imagination. But part of it is that we develop all of these sort of systems for taking in say what we see or what we hear or what we feel and touch, and we do that through experience. Like you're when you start seeing things from when you're an infant, you start developing the networks and things that are responsible, that are going to respond to what you're seeing. But even when you're not looking at things like those areas that you developed, they can still be active. So in that you can sometimes that comes in the form of imagining like what you might look at or what you could see. But sometimes it's also might be a result of, like maybe the lighting conditions aren't so good. Has anybody had that experience where it's kind of getting dark, and say you go outside and you think you see something that's not really there, but then you get kind of closer and it's something else, like it's a bag or something that
Yeah, that happened to me.
right? Yeah. So so sometimes you can actually, and this happens actually quite often when people get older and their eyes aren't working as well, that maybe the those areas that see things, they can still be active even if you're not getting as good information from your eyes. So you get kind of hallucinations of things. Sometimes people can really tell that those aren't really there just because they don't make sense to them. But sometimes you might not be able to. So that it is actually, I mean, it's a good question because we make sort of predictions about what things are and what's going to happen, but it's not always right. So the brain can't always tell what the difference between imagination and what's really there.
That is an excellent question. Does Kareem, do you have a question too?
So yeah, I have a question. How the flashbacks happens?
So if you have a very intense experience, right? Like some kind of a powerful sort of traumatic experience,
Yeah.
the brain is very, very focused on like all of the aspects of that moment, like all of the stimuli, all the things that are happening. And I'm going to try to use an example, that's not maybe so triggering, but like, for example, like somebody has like a terrible car accident or something, then the sound of a car, the sight of a car, the sight of a road, the sight of road signs and things like that, honking of a horn, all those things can be linked now to a very powerful kind of bodily response. I think Natalie was mentioning earlier the autonomic nervous system. So this can sort of, you don't have any control over this. It's when you detect that stimulus, you're gonna feel like in a panic mode. Your heart is gonna be racing, your mouth is gonna be dry. You're gonna have this what we call a fight or flight response, actually. And so even when the context is different, like even when you're not in any immediate danger, like from the cars that are passing, you will feel as if you are in danger. It'll call up all of the associations, all of the memories that are linked to that specific traumatic experience. So yeah, that's a powerful question, actually, because to deal with that is very difficult. Like how do we deal with that, right? And so there have been some kinds of therapies that have been developed to try to help people in those circumstances, to try to reduce the intensity of the association between stimuli and your bodily response to those stimuli. But it can be a very, like, it's, when you're having those kinds of fight or flight responses, it's like, I mean, that's just the reality that you're experiencing. So, I mean, it's not like people telling you that that's just your body responding and you're not in danger. That doesn't have much of an impact actually on your actual experience because you're having that experience, right? So. You know, the amygdala, which you guys learned about, right, from Abdulrahman when he was talking to you earlier, is very much involved in this response too, because stimuli that it's an important memory structure. You know, it's tightly tied into the hippocampus, and it's very important for like remembering stimuli, remembering things in your environment that are emotionally significant, that have a pretty, that often like might put you into danger if they're present, or, at least require a very heightened kind of bodily response or, body and brain response.
Yeah, the example that we guys learned through it, if you guys remember, it's when we encountered a megalodon and we were in a submarine and there was a little fish. So how did these two basically interact with the megalodon? What did the submarine do and what did the fish do?
Sir, sorry to interrupt, but I'm currently in a cafe and I have to go home because it's really late.
I'm not hearing, but I know someone is talking.
I said that I was in a cafe and I need to go home because
The fish ran
it's very
away.
late.
Okay, no worries.
Okay, thank you.
Can I say something?
Yeah, please.
But it's like about when you were talking about the the car crashes and stuff like that. I heard it's something. It's like called PTSD or something like that.
Yeah, that's exactly it. That's exactly. Yep.
Stress disorder.
Yeah, that's exactly what that is. Yeah. That's what they would term it, like medically, like that would be the clinical diagnosis to some extent. Often, is there are other forms of the disorders. Like sometimes people actually have what's called a panic disorder, and this is actually not necessarily related to any specific traumatic experience, but the circuitry, the wiring, the neurons, right, that connect from your brain, to your body to drive these autonomic responses, they could misfire, for some reason. This could happen actually to almost any of us sometimes if we're like really stressed, if we're like not getting good sleep again, right? There could be kind of a misfiring of these systems. They're not being very adaptive in that circumstance, but you could suddenly have this powerful, intense, like kind of autonomic response, and your heart is racing, etc. And in those moments, also, people are really going to be looking around, like what are what precipitated this? What caused this? And you may form some associations in those experiences that could make you like concerned about going back to that same location, or doing whatever you just did before, even though it really didn't have anything to do with that. It happened just because of what was happening in the circuitry of your own brain.
Can I ask a question?
Sure, Selma. Yeah.
Can PTSD be completely cured, or is it a lifelong condition?
That's also a wonderful question. So, a lot of the focus on treatment is to kind of minimize some of the impacts, or to reduce the impacts of the experience. So one of the things is people tend not to ever forget those experiences, but the goal is to try to make that so they don't interfere with your life as you go forward. So you are going to be informed by those experiences, and it becomes, you have to kind of incorporate it into part of the story of who you are and what you've experienced, etc. But to reduce the autonomic response, the unbidden sort of autonomic response, to gain more control, over its expression. And yes, there are many cases where people are able to do this actually, pretty effectively. It requires, people caring and connecting, and all sorts of, a huge part of it. And Jeff, maybe you want to mention this too, right? Is the ability to kind of find some form of expression of what happened in a way that doesn't trigger you to that same degree. Like there are some remarkable, powerful art responses, like making things that reflect aspects of the experience and sharing it in that form. Because sometimes it's really hard for us to verbalize some of these things or talk about them, but to create something. We've done some work, right, Jeff, with folks in Chile, in South America, where they have an incredible kind of art tradition. Do you want to describe arpilleras or?
Well, they were making they call them arpilleras, but it's tapestry that they make out of fabrics and clothes, and but they depicted memories and things that had happened, and but part of that, it allows you to sort of tell that story, but in a way that isn't going to, necessarily, or helps you tell that story in a way that's not going to provoke that sort of autonomic response that Bill's talking about, like that really powerful kind of fight or flight response that you get. And part of this too, is it's really, we kind of remember things through stories and through our narrative. And so being able to tell these stories, it not only helps us, but it maybe allows us to see how things could be different in different circumstances. Like you could tell a different story, and that's a lot of what we do with art. We tell stories, and we tell and these stories don't need to have the same ending every time. So that's what they do with these arpieras but lots of different artworks that you can make. So
we do want to say that actually, we're hoping that actually the Found Neuron project, we're really excited to return and, take more questions and also see the work that you create, like see what you want to make and see how you make it. We're really interested in like the materials that you choose, like the stories behind, what you find to, create these cells, like what do they mean to you and things like that. So we're planning to return, right, Abdulrahman? So we would love to, see
inshallah, in March 4th.
Yes.
Yeah, we will be coming back with Noggin, and we're gonna be seeing the projects that you guys do. So everyone get the chance to open their camera and demonstrate it. And also you can share the pictures with us as well. So I'm so excited. I know they're gonna be super creative, super interesting, and I'm so excited to see them. We Let's just take two more questions, and then we can um, end the session for today. Or actually, one question is from Kareem, and then we can end the session for today. Again, thank you so much, Noggin, and all the team for coming here today. I loved the session, and the students loved it. I can speak for them, and they will give feedback now. But thank you so much for um, this visit. So, Kareem, let's finalize with your question. Okay, he's not hearing us. All right. So maybe Kareem doesn't have connection, but any other students want to say some concluding comments before we end the session for today? Anything you learned? Anything you would you just want to tell Noggin or me?
But I enjoy with this session.
Thank you, Tala and Ratil.
Thank you very much, you guys. Yeah.
Thank you very well.
Thank you,
Very
Mohammed.
We
Thank
enjoyed
you.
and learned a lot.
Oh, that's awesome.
Yes, we learned a lot of things.
We learned a lot from you. Thank you guys very much for inviting us. And Abdulrahman, thank you so much for putting this together. We really appreciate it. We're excited to come back.
Thank you so much.
Of course.
Thank you.
Thank you for having us.
Thank you very much.
Thank you for your time.
Thank you.
We'll see you guys in March, right?
See you.
Take care, guys. Okay, bye.
Bye.
Thank you.
See you again. Bye.
See you again.
See you next session, inshallah. Goodbye.
Goodbye.